Let's look at this example question here. If you're given the specific heat of water is 4.184 joules per Kelvin per gram, what's the heat capacity of 100 grams of water? How is heat capacity related to specific heat? Very good. So multiply the specific heat, the heat capacity per gram by the number of grams, right? So that's going to be equal to 4.184 joules per Kelvin per gram multiplied by the mass, which is 100.0 grams. And that's going to be equal to 418.4 joules per Kelvin. Reciprocal grams and grams cancel out. Okay, so the unit for heat capacity is just joule per Kelvin or joule per degree Celsius. How much energy is transferred when 100 grams of water at room temperature, 25 degrees, is cooled to 15 degrees Celsius? What would your formula for that one is? Q, right? Equals C delta T, right? Or you can say mass times specific heat times delta T. Remember, mass times specific heat is the same thing as big C. Okay. So either one of those two. Well, we've already calculated the heat capacity of 100 grams, so we already did this part right here. So let's go ahead and just plug that number in. 418.4 joules per Kelvin multiplied by delta T. What's our delta T? Delta T is final temperature minus initial temperature. Okay, so that's going to be 25.0 degrees Celsius minus final temperature is 15, sorry. 15.0 degrees Celsius minus 25.0 degrees Celsius. Okay, let's look at our answer here. It's 418.4 joules per Kelvin, and that's negative 10.0 degrees Celsius. Okay, do I change this to Kelvin? And what would it be if it's in Kelvin? To change Celsius to Kelvin, you add 273. Do I add 273 to this one? You don't, because when you're looking at temperature changes, the temperature change in Celsius is the same thing as temperature change in Kelvin. Let's understand why that is. This is minus 10 degrees Kelvin. Minus 10 Kelvin. You don't say degrees Kelvin, okay? Let's see why that is. To change 25 degrees Celsius to Kelvin, you add 273, right? So that is 298 Kelvin. So I just say 25 degrees Celsius plus 273. That gives me my initial temperature in Kelvin. And to change 15 degrees to Kelvin, I add 273. So that's now Kelvin, right? If I take the difference in the temperature, what happens? If I subtract, well, the 273 will just cancel out. It's still going to be 10.0 Kelvin. This is really 298 Kelvin minus 288 Kelvin. 10 Kelvin. Okay, actually, I got it the other way. So I subtract the other way. It's negative 10. So a change in Kelvin, a change in Celsius, in degrees Celsius, is the same thing as a change in degree in Kelvin. Okay, so I could have just written this. I can just say this is the same thing as negative 10.0 Kelvin. Okay, so the answer to this question would be 418.4 times 10. That's going to be 4184 joules. Okay, Kelvin cancels out, and it's going to be negative. And let's check our significant digits. This has 3 significant digits, 10.0. That's 3 sig figs. This is 1, 2, 3, 4 sig figs here. Okay. So this should have only 3 sig figs. So my last significant digit is the 8. So I have to round this off to negative 4180 joules. That's key. What does a negative value mean? Heat went in or out of your system? Okay, so when your water cooled from 25 to 15, energy went out of your water. So the atoms in your water becomes more sluggish. They lose kinetic energy when heat flows out of your water. Okay? How could that happen? You have to put your water in contact with something colder, like you put it in a freezer where the air is colder than 25 degrees. Okay? Or you have to put ice around it. So that's the way you can get the energy to go out of your water. Put it in contact with something colder, something whose average kinetic energy of the atoms is lower than in the water itself.